Hey, good day, guys. Welcome again to my channel. Welcome to Slab Reinforcement Detailing 101. All right, in our last contact, I was able to show you how to perform slab reinforcement detailing up to the point where you can position your bottom reinforcement and the bottom distribution reinforcement. All right, so at the end of that exercise, we're able to get ourselves through to this point. So in today's video, I'll be showing to you how to carry out your slab reinforcement detailing, then how to position your top reinforcement and the top distribution. Then in subsequent videos, like I promised, I'll be showing to you how to put all things together to have a complete reinforcement detail. All right, so thank you very much for all the reactions in the comments in the last video. It showed to me that you got all I said perfectly, and I'll make another attempt to see that you are good to go in this video. All right, so this is a general element drawing of which I explained what exactly is a general element drawing. You can check the description of this video. I pinned a link on that description to how to create a general element drawing. So if you're new to structural engineering or how to make general element drawing, you can use that link and you get yourself better by that. All right, so to go ahead, I show to us that we are detailing the slabs, this particular slab, according to BS8110, and I showed to us a guide to our reinforcement detailing, and I'll be bringing that guide back to our face today so that we can get used to it. All right, so we have this, as you can see on my screen, shows that for continuous internal support. Now the top reinforcement, basically they are also called the support reinforcement, so you find them at the support of the arrangement of your slab panels. All right, so as you can see on the right, it says continuous internal support. So our top reinforcement, like I said, would be on the internal supports. So if you have a reinforcement at the top, this basically you can see here is the top reinforcement that my cursor is pointing. All right, so if this is the top reinforcement, the code says you have 0.3 multiplied by the span to be the minimum um, length of that support reinforcement. All right, so it means that whatever span you have on the adjacent span, whatever it is the greater, whichever is greater, would be multiplied by 0.3. Then you have the minimum length of your top reinforcement. All right, so how do I mean? Let's get to practicality of what I just said now. Okay, so as you can see here, we have supports, internal supports on axis B, grid line B. This is a beam support here. All right, and on grid line 2, that's another internal beam support. So it means that our top reinforcement would be over beam B and over beam 2, because those beams are the only one that we have internal. All right, so this is how we're going to do it according to our code. What I just showed to us now, it says we have 0.3 of the adjacent span, or the greater of the adjacent span. What it means is this: your span on the left and your span on the right, whichever is greater, you multiply by 0.3. All right, whichever is greater, you multiply by 0.3. So in this case, we have equal spans to the right and to the left, so that's 4 meters. So we are going to do 4 meters multiplied by 0.3, that's 1.2 meters. All right, so what you're going to have from the face of your beam is going to be 1.2 meter. All right, so that's what we have. Then you move from there to the other span, 1.2 meter, as the code recommends. So you see, as it is, basically that's your top reinforcement for that beam. So how does it work? How much does it span? So let's get to it. So to use this that we've been using, so let's get this down to this place. All right, so this calls out this particular reinforcement. Then we can move this a little bit away from that reinforcement. You see that? So let me take this out. All right, so it spans from here down to here. Also, it can span from here to here, and that's exactly what I'll do now, because it works all through. Adding being you are having varying dimensions on this side of the on this panel, all right, or on this panel, different from what you have above, then this might not be sufficient to cater for this panel, this support, especially when the panel is bigger than this that you have here above. Let me try to explain again. If what you have here on the right and on the left varies from what you have on this panel down below on the right or on the left, this reinforcement that we have provided here might not be sufficient to run through onto this point. So it will be safe to create another reinforcement for this support. That's exactly what I'm saying. But in this case, it works all through, seeing that the dimensions are typical. All right, so we want to retain what we have up above. All right, so it works to this point. Good. Then how do we know the numbers with which would have, how many numbers of reinforcement would have? So we have 3775. So like we did in the last video, 3775 divided by we assume a spacing of 200 for the main reinforcement, for the top reinforcement. So we have 18.8, that's 19 plus 1, so 20. But then it's spanning across two of that panel, which is 40 y12 19 200 center to center top. All right, it's a top reinforcement. That's it. So let's take it on for this side also. All right, the same thing happens on that side. 0.3 of 4 meter would give 1.2, like we have said earlier. All right, on that side, and on this side, on the other side, we have the same thing of 1.2. That's it. Then we have our call out bar. All right, let's just take this from here. Then we have here, so I can span from here down like I did. So it works from the beam, from the first beam on the left to the internal beam. All right, this works from here to here, and also works from this support down to this support. So we can have this copied to the other end. So as in the case of what I explained concerning this reinforcement here above, this also, if you have a varying dimension of the slab, of this slab, all right, from this, then it might not be sufficient to cater for this support of this slab. So you might have to create a separate reinforcement for that support. So this will be 40, and this one also will be top. Now, how do you, since we have basically done all the top reinforcement that you can see here, basically, how then do you cater for the top distribution? All right, so the top distribution runs between two top reinforcement, all right, and it distributes the top reinforcement. Okay, so let me just explain so that you would not be confused to that. All right, so if you clearly got this I've done, then you are about to get this other one I'm about to explain. All right, so let's merge the two together. I have this already. All right, so, and everybody gets this clear. So I want to bring what I've done here, and then I fix with that. I want you to understand the top distribution in this very simple way, and that's why I'm doing this. All right, so I'm copying this that I've done here now on this. All right, you see what we have. It makes sense in it. It does. So we have this. Now I have combined the bottom reinforcements and their distribution with the top reinforcement. Now it's left with top distribution. All right, okay, so this, we can change this to slab, reinforcement details, since it's going to form the complete detail we need. All right, so we have the top reinforcement. Now to do the top distribution, now it's simple. Now it's going to be, I said it's going to be between the end of a top to another end of the top, all right, to distribute another top. All right, so this is how it works. This is a top reinforcement. It needs distribution. It needs a distribution bar. And then how much is this going to be without having a distribution? That's where we need to create a distribution bar. So it's going to be between this top and this top, all right, to form an horizontal setup. So we have between this top, this now, from here, and then between that. So we have an horizontal reinforcement that way. Why is that? Because if this spans all through this beam, for example, this also spans all through this beam, for example, when it gets to a section of this arrangement, it will distribute each other, all right, and also this and this will distribute each other when it gets to this angle, but at this point it will be empty. So that's why we have to create another reinforcement to distribute this arrangement. The same thing happens to this. So how do we call it out? So we have something like this. Just pay attention to me. All right, so this, now that reinforcement will span to distribute this, all right. Also it will span to distribute this, to span to distribute that. You see that? So we're talking about this reinforcement to span to distribute this, and also span to distribute this. So if you have a question about this, please do use the comment section. I will be there to answer to all that you have as questions. All right, so to go ahead to call this out, all right, so let's assume it's 300 spacing for the distribution, and we're using a 10 mm reinforcement. All right, so how it's going to be from here to here, how much is it? 600. Like 600 plus, from here to here, how much is it? 1.2. So that's 1.8 divided by the 300 spacing. That's 6 plus 1, 7. So we have 7y10 at 300. So it's going to be, yes, that's exactly, you got it, top distribution. All right, so the same thing happens also to this. Because of the typical span that it is, what happens above here can also happen down below, or will also happen here, because of the typical arrangement that we have. So this and this, whatsoever happens here also happens below. You see that? So it spans here and also spans to distribute the support. So it means this becomes double, 14 numbers. All right, so the same thing happens on this side. All right, so this reinforcement spans all through this span. All right, so you need to show this top distribution on this side also. All right, so you can just copy it since it's the same, but in case it's not the same, you have to create something that works for that panel for it. All right, so this stays, it's just right here. So then we would need to call this out. Need to call this out. Let it stay here. Yes, so this top distribution, and then this is it. So it talks of this reinforcement here. So you can take this, for clarity's sake, away from the line. All right. So as much as you're detailing, you are pursuing clarity in your informations. All right. So you see that this on the left also works for that on the right because of the typical spans. I need to really highlight that. So if you're working on varying spans, you have to create what works for that particular panel. All right. So on the other direction, I mean this direction, we need to distribute this reinforcement. We have clearly distributed this reinforcement, this top reinforcement. So we need this reinforcement to, we need to provide a top distribution, which is going to be between this, just like I did previously, and this. Then we have the bar. What I did on this horizontal is between this top and this top. Then we provided this to span all through on the top reinforcement. You see that? Then on the other end, it will be between this and this to span between this and this. Very, very clear. All right. So if you still do not understand that, I'll be in the comment section as there to answer to all your questions. All right. So let me take this away from there because I need to call out horizontally, and I need my detail to be as clear as possible. All right, I'll stay here. Then I would want to call this out with something like this. All right. So let me call to the right. But then this dimension, I'd like to move away from the 14. All right, so good. Okay, so we have this now. It walks all through to this place, and it speaks of this reinforcement. So it works between the first this and the end here, and also this works from the beginning here to the point here. You see that? And the same thing happens on the right because of the typical dimensioning that I spoke about. All right, so it's going to just be like this in the mirror. No, then we can extend the call out up onto this point. You see that now? So it works all through to distribute this part on the left, distribute this part on the right, and distribute this top when it gets there. You get that now? Okay, so that's the top distribution on this side. So seeing that you have the same dimensions or span up above here with the one that we have down here, so you may just want to mirror what you have up above in this case to the other panel below. All right, it's as simple as that, so that what you have would be this. Okay, so we need to copy this also. Okay, to make it clean and clear, I would like to move this. All right, then this also to sit where it ought to, then this a little bit clear away from this call out. So as much as you're trying to pass your detail, your information should also be very clear, and not all. Yes, so this is it. So this also works from here to here. All right, then to this place, and then covering this place. Okay, so in this case there is something unique. If you discover that this top reinforcement ends here and the cantilever reinforcement here ends here, so it means that your top reinforcement, this might not work or should not span all through this place just this way because of this arrangement. So you may need to just take this off and delete this off and this. All right. So what you have here should be 7 and not 14 anymore. See that? Now you may not need to create a top reinforcement on this axis, seeing that the difference between this and this is very, 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 very small. All right. So you may not need to create, for example, if you make an attempt to do that, I just want to show you how small the reinforcement may be. So it's going to be something like this if you want to create it. All right. So for the purpose of this class, I would do it. All right. So that you can use this to learn the detail the proper way. All right. But in practical sense, you may not need to. You may just need to extend one of those bars to meet up with the other one, and then you move. Okay. So what is going to be like is this. This is also going to span more like this that you have already. Okay. So it's not joined. Okay. So this is it. Then you have to call out that small bar, fix it here. Then this also. So you see that now. So that is exactly how we go about this. So that basically forms the distribution all through for this setup. Now you see when this gets here, but this one now, I just saw something. When this reinforcement distribution, this distribution gets to this point, it should not stop here because of this cantilever top reinforcement. All right, it should span up until this point. All right, because this top reinforcement gets to this point. So that will increase our number of reinforcement. Yes, 1.4 divided by 7 divided by 300. So we have 5. So that's going to be 19 added to this. All right, so this forms a complete reinforcement, slab reinforcement detail. All right, so in the next video, I will make an attempt to show you how to cut a section of your slab detail. All right, because it highlights certain things you've done on plan, as you can see here, and it shows the in-depth details of that particular section. All right, so to complete this detail, we want to arrange the bar marks, because the bar marks helps you identify what a bar from another. All right, so we just want to call them, either you go anti-clockwise or clockwise, whichever way, or you number them accordingly, whatever it is that suits you. It's just for identification purposes. All right, so this is 04 and this 05, then this 6, 7, you have 8, you have 9, you have 10 for this, then this one you have 11, and this you have 12, and this you have 13, and this you have 14. All right, so this completes the bar mark arrangement of your slab detail. So if you have any questions as touching these slab details, as I've shown you in the last two attempts video, part 1 and part 2, you can do well to reach out on the comment box, as I'll be there to answer to all that you have concerning this. All right, so you will do well to like this video and subscribe to this channel. I have amazing video coming your way in the next few days. See you in the next video. I'm Joshua the Designer. Bye.